So when looking at actually starting this one, that question does come up first of, do I have to multiply them together or can I take the derivatives now? Well, if I just took the derivatives at the start, so like I find the derivative of this, and then I find the derivative of this one, what would I do with those derivatives? Would they just be multiplied together? Well, that wouldn't quite work. Because remember when we first wrote down like the sum of derivatives, we took that little rule down in our derivative notes. We found that if we're adding them, we could just find the derivative of each term, but I specifically mentioned then that we cannot necessarily do that if they're being multiplied.
Why?
And so the multiplication, it doesn't quite work. Now, let's actually take a look at why that would be. If I take the derivative of this first term, that's going to give me 45x to the fourth plus 7 times 12x squared, actually just 12x squared. Okay, and just for comparison's sake, I'm going to multiply that out. So if we actually multiply that out.
Math skills. You almost killed me, dog. Don't talk about it. My card was more than halfway out. You pulled out before me.
So this is what we would get if we actually just try to take the derivative of each one. But if we instead multiply it all out, which is what we're going to end up having to do here, what would it look like? And so the first thing is go ahead and multiply the two binomials together.
So is the first one wrong?
Yes. Okay. Oh, so you were supposed to multiply it out. Oh, I got it right there. So he tricked us? Yeah, he tricked us big time. That's not cool.
Okay. After multiplying it out, then we can go ahead and find our derivative. So when we find the derivative by actually multiplying it out, which we know we can do, you end up with this. Well, we know that this would be correct. But was this correct then?
No.
Obviously it doesn't equal the same thing, right? And so you can see that by just trying to take the derivative of each part by itself, it doesn't work out. And so we can't just do this technique. This is not going to work for us. But there is another way that we can deal with that. And so that's what we're actually going to be learning today, is how to do a derivative like that. And the first one that I'm going to use as an example is this one. Because you'll notice g of x equals e to the power of x times the square root of x. Here we have two functions that are being multiplied together because e to the x times square root of x. But there's no other way to simplify it. I can't just make that into something that I can use power rule with. And so instead we need a new rule. So on your derivative rule sheet, we are going to add today the product rule.
Yeah.
Now this is kind of ugly to look at, but hopefully not too hard to understand, because notice we have f of x times the derivative of g of x. And then we have g of x times the derivative of f of x. That's really all that means there. But of course, there's a lot of symbols all overlapping in there. It's a lot to deal with. So if you want a simpler version, it's not necessarily great form on our technique to mix the d over dx notation with the prime notation, but it sure makes this easier to remember. So you might want to also add this way of writing it to your notes, because it means the same thing.
Oh, that's exactly what it is.
But it's a lot easier to remember and a lot easier to look at. So, basically what we have here is that in order to actually find the derivative of a product, so you got a function times a function, you do f times g prime. So in other words, you got to kind of see it as the product of two separate functions, which we'd call f and g in this case. So you do f times g prime plus f prime times g. It's just one way to remember it. You'll notice, since we're multiplying, the order of the multiplying doesn't matter. So if you remembered it as g prime f, same thing. Since we're adding them, if you switch the order, it'd still equal the same thing, of course. This one's pretty forgiving. All right, so now we're going to practice that with this problem here, the same one that you saw before, where we have e to the x times the square root of x. So again, you need to think of it basically as two functions that are being multiplied. So I have the e to the x, and that is being multiplied by the square root of x. So that's kind of like saying that's playing the role of the f and the g from our rule. So if I want to then find this derivative, so it's going to be g prime of x equals, I'm going to do f times g prime. In other words, I'm going to do the original function times the derivative of the second function. So the original function, of course, is e to the x. And I'm going to now multiply that by the derivative of the square root of x. Now that one's probably come up often enough that you just remember it at this point. If not, go through the work. But it ends up equaling 1 over 2 root x. And then we do plus. Now we do the derivative of the first function. So I do the derivative of e to the x. That's the one we just learned yesterday. What's the derivative of e to the x?
E to the x.
Exactly. It is just its own derivative. And then that is then times the second function. Just the original second function. So that's just going to be square root of x.
So where does that get us?
So it doesn't change.
And so then
It just adds stuff.
the actual derivative is, I could clean that fraction up a little bit and just put the e to the x on top. E to the x over 2 root x plus e to the x root x. And yeah, the question then ends up coming up, well, why did we want to do that? It looks more complicated. This isn't about making it simpler. It's about actually being able to find the derivative. Because without that product rule, we could not have found the derivative of that function. It would have been impossible.
Is that the...
So now if we go back to where we started with this function, we actually could have found the derivative without multiplying it out, but we would have to use the product rule. And so I actually want to go through that exercise and see what would that look like. So go ahead and on your own, find the derivative of this using the product rule. I wrote the wrong thing on the slide here. That should be product rule. But go ahead and do this problem using the product rule, please.
Okay, Mr. Morgan, everybody.
So as you're doing it, those are your two functions that you're looking at. So it's basically the two parentheses represent your two functions. Now, by using product rule, we were able to go straight to the derivative. We didn't have to expand it out first. We were able to go straight to the derivative. If I wanted to, like if I had a value for x, I could just start plugging that in for x's all the way along here. Or I could even multiply these out and combine the like terms. By the way, multiply these out, add them all up together. You do get that same answer as what we got before. But the nice thing about product rule here is, you didn't have to, did you? Because we actually have the derivative at this point.
So you just leave it at that?
You can just leave it here.
Oh.
Yep, you have options.
Because that's the derivative.
Sometimes the question that comes up along the way is, okay, yeah, but does it work with all the other rules we've had? You know, what about that derivative of like 15 times x to the fourth? If I actually look at this as h of x equals 15 times x to the fourth. So like the 15 is a function and the x to the fourth is a
That's
function.
mess. Why would you do
Will I get the same answer by using the product rule?
that? Yeah.
Because then
Do it. Let's see. All right. And so if we go and use product rule with this from here, we do original of the first times the derivative of the second. So that's 3x to the fourth, 4x cubed. There we go. Plus the derivative of the first part. Now what is the derivative of 15? It is 0. Because 15 is a constant. And so you'll notice then the 0 times x to the fourth is just 0, so it equals 15 times 4 is 60 x cubed, which is the same thing we would get just by using power rule and that constant multiple rule that we had before. So yes, it still fits. And in fact, the constant multiple rule was just product rule in a simplified form. So you didn't have to do the extra addition. So for this, when we go to find the derivative again, we have to kind of plan ahead. What technique do we need to use? Of course, this is product rule day, so you can guess that it's going to be product rule, and it is. But the first step here is you have to decide what will the two parts of the function be. And the way I look at it is I see it as 4x squared and e to the x as being my two parts. All right, and so then if I'm going to use product rule to find this derivative, f prime of x is going to equal the derivative of, actually no, I keep the 4x squared first. Sometimes I'll take the derivative of that first as a matter of habits. But 4x squared, now I multiply that by the derivative of e to the x, which is just e to the x, plus, now I do the derivative of the 4x squared, which is 8x, and that's times the original function of the other, which is just e to the x. And so then this would be it. You can give this as your final answer. Now you can manipulate this answer in different ways, like you could try factoring out an e to the x or something like that, but we don't need to. This is fine for our final answer here. A side note here, if you had done it in a different order, if you had done the derivative of this first and then done that, well, you'd still end up with the same answer, right? It would just be 8x e to the x plus 4x squared e to the x.
That's crazy.
Same thing, right? So you're still going to get the same answer whichever order you do it in. So I made an arbitrary choice when I started this to go ahead and just start by using product rule, where I was seeing it as x to the fifth times the parentheses. It was an arbitrary choice, though, because you could also multiply that x to the fifth in at the start, and you're still going to end up with the same final answer, which is why in this case, just so that we can actually check it out and make sure that we do in fact get the same thing, let's actually multiply it out and see that we do get the same things.